Hello. Good evening, all, and welcome to tonight's Arboricultural Association Wednesday webinar, sponsored by Still and hosted by me, Association CEO John Parker. Welcome, one and all. Please say hello in the chat. Let us know where you're watching from, particularly if you're watching from Mexico, and use the Q&A button for any questions that you might have. Tonight, we've got a bit of a change in our schedule because, unfortunately, Rob McBride is unwell and will not be able to join us. So, Rob, we wish you all the best, mate. Hope you feel better soon. However, the good news is that Dr. Cecilia Chavana-Bryant has agreed to speak for a little longer than originally planned about the fascinating scatter project. So we might not go the full hour and a half. It might be a little bit shorter. Obviously, you'll get a full refund of the no money at all that you spent on this webinar, but you can be free to go and do other things, pursue other hobbies, do a jigsaw or something of that nature if we finish a little bit early. Next week, our guests are Nadina Gallet and Justine Cast. Nadina will be talking about her book, The Nature of Cities, and Justine will be giving us a thought-provoking analysis of the Wood Wide Web theory. Two great talks not to be missed. And then the following week, December the 11th, we have a real treat. Saeed Gadari will be presenting her season watch project live from India, and tree legend and all-round good guy Tony Kirkham is going to be suggesting some trees for the future. So if you fancy a big argument about native versus non-native trees, then December the 11th is for you. And you can sign up free for them and the other webinars of this series online now. And also, for all you people out there wondering, you can also now buy your Christmas jumpers online, as well as loads more merch from the Arb Association. So get shopping now. On to business. It is my very great pleasure to welcome this evening's presenter. Cecilia, it is over to you.
Hello, everyone. Thank you for being here. Let me just start sharing my presentation so we can get started. There we are. So thank you, first of all, to Emma Gilmartin and John Parker for this invitation. This is a really special talk for me because I am actually a tree climber. And I was trained by two wonderful arborist friends, Olivier Jaudon. I'm sure I'm not pronouncing his surname correctly. He works in, he helps scientists to access the canopy in Brazil on very exciting projects there. And Mick Eltringham, who is a British arborist, and I think he's in the audience. Hello, Mick, if you are. And Mick is a really shy guy, so I'm going to embarrass him by saying that he was an amazing teacher. He helped me, he trained me in ARB techniques to move around the canopy. And with those techniques, I spent 2 years in the Amazon, climbing some of the tallest trees in the Amazon, and it was an amazing experience. So I'm really happy to be giving this talk and give back a little bit to these wonderful profession and its wonderful practitioners that have helped me so much in my own scientific work, research. So anyway, let's get back to the business at hand. And so I haven't even told you my name, Dr. Cecilia Chavana-Bryant. I am a postdoc at UCL. And I will be here talking today about the scanning ancient trees with terrestrial LiDAR, the scatter project. So let's start by giving you a little short introduction about the two main themes of this project, TLS, terrestrial laser scanning, or LiDAR scanning, and ancient trees. So let's start with TLS for now. And oops, my presentation is not moving. Here we go. So this, as you're seeing here, what is terrestrial LiDAR scanning? You're seeing here a project in Wytham Woods outside Oxford. And basically, terrestrial LiDAR, it uses 3D cameras that have a laser rangefinder that fires thousands and millions of lasers and create basically literal point clouds. Wherever they touch, they create a point. And what you're looking here are scans from a 1 hectare plot in Wytham Woods. You can see some of the scan locations there. And basically, we scan in forests, we scanned 1 hectare plots, 100 meters by 100 meters on a 10-meter grid. So we collect a scan every 10 meters. And with these, we make a whole scene of the forest, as you can see. And these are all literal point clouds. So there is nothing solid about these data. So why do we do this? What is the usefulness for this data? So basically what TLS does is very good is at mapping the architecture of trees. So when we scan a whole plot, a 100-meter plot, for example, this is what we're after. What you're seeing on the screen right now are the 845 trees that we extracted after a lot of processing of the data. Takes about a week's worth of data processing to get to the point where we can extract individual trees. And then we separate leaf and wood from these trees. And also we are able, so once we have these individual tree point clouds, we're able to model all the points get put together into a mesh. And so we can then, all basically the canopy structure gets modeled into cylinders, all the branching and all that. And so we do this so we can calculate volume. We can then calculate how much carbon, how much above ground biomass this tree contains. And for example, here in all of these trees that the trees that we extract are 10 centimeters diameter at breast height, DBH. We don't do the smaller trees because they get very mixed with the ground vegetation, so we can't really extract them that well. And however, out of these trees, all these trees that have been extracted from 1 hectare of forest at Wytham Woods, you can see that basically 50% out of all of these trees that you're seeing, 50% of the above ground biomass in this 1 hectare of forest is contained within 5% of the trees. So 40 out of the 845 trees that you see here contain 50% of the biomass. And why is this important? It's really important because with what these study help us realize is that our carbon estimations, our AGB estimations of these forests are really underestimating the amount of AGB that is there in our forests. And the reason being is that before LiDAR, if you're not using LiDAR, you're using allometric equations to calculate above ground biomass or carbon content of trees. And that basically that calculation is based on the trunk, on the height and the DBH and the width of the trunk. So you're really not considering all the branching or the canopy. And so but a lot of the carbon and above ground biomass is contained within these kilometers of branching that all these trees make. So it is not surprising also that we found out with this study that previous estimates that had not been done with TLS, where our TLS estimate was actually 1.8 times higher than previous estimates. And it's not surprising if these other studies have been based just only on the trunk and the biomass that is there. So two things that TLS do very well is map the tree architecture to millimeter precision. And this allows us to then calculate carbon and AGB. And so let's move on to ancient oaks. So, and then we'll get around to how we bring these two together. So ancient oaks, what is an ancient oak? Right here, I'm showing you at the moment the life cycle of an oak tree. Oaks generally live for up to 1300, 1400 years. And as you can see, I mean, a tree, of course, a young tree starts with very simple architecture. And as time goes by, you will see that that tree starts growing up, and it starts, as time goes by, it's competing for light with other trees in the forest. It's a storm might break a branch, things like that. So every tree is quite unique in the way it develops its canopy, because it reflects its immediate environment, what happened to it as it was growing. So once it gets to 300, 400 years, an oak becomes a veteran, and basically its basic structure is there. And from then on, it's just basically growing that structure. And as you can see after that, there is also another important thing that happens with time, because trees are super fascinating in that they are both alive and dead, because they have structural wood. So actually, I'm sure this is not a surprise to this audience, but the part of a tree that is actually alive is 1 to 10% at any time in its life cycle. So basically, we're talking about leaves. We're talking about the cambium, which is right underneath the bark, and then the xylem and phloem conducting elements, and the root tips. And apart from that, we're talking about structural wood, so hardwood. And so as years go by, as centuries go by, that structural wood starts to decay. So the tree is growing and decaying at the same time, which I find absolutely fascinating. And so the one big characteristics of these trees is the wide girth. So once they get past veteran stage, they start becoming quite chunky. And it depends on, of course, the ancient or veteran status of a tree depends on the species and how lonely that species is. And there is actually a rough relationship between the girth of a tree and its age. In oaks, it's generally roughly 100 years per meter of girth. And if you can see right there, the range in girth of our scatter trees was 3 to 14.78 meters. The 3 meters coming from a veteran, and the 14.75 is the Morton oak, which is not the oldest, although it is over 1,000 years. But the trunk, that girth includes, the trunk has actually split, so it's not a solid trunk anymore. So there's a lot of space in that girth. But so as you can see, different tree species with different life lengths will achieve veteran or ancient status at different times. And so let's talk about some more of the characteristics of these ancient trees. We have, of course, like I said, with time, there's growth and then there's decay. And so the trunk hollowness of these trees is a feature. And sometimes you can see an opening to the outside, sometimes not, depending on where they are in their decay. In the stage of decay. And this is something else that brings another fascinating thing that these trees do. And as their trunks start decaying, it releases nutrients and locked up in the hardwood. And these trees actually start growing aerial roots towards the inside of the trunk, and they effectively recycle themselves, which is, I find it astonishing and a super beautiful concept. So another thing that they do, so as they start decaying, branches can start collapsing. The trunk parts of the trunk start collapsing, and so the canopy tends to contract due to a natural process of retrenchment, where the gradual dieback and branch loss rebalances the leaf area to root system, or with pollarding, with the work of some of you guys that are specialized in ancient trees, and it can be a human-made process with similar effect to retrenchment that makes these trees live longer. Basically the decay is more controlled, and so yeah, it's a different way to go. And then, of course, these trees end up being small, having small canopies and wide trunks. They're quite chunky. And this offers them wind protection. And also, personally, I think this is one of the most beautiful features, the stag-headedness, the dead antler-like branches that start that remain when there's branch collapse. I find those features really, really beautiful, apart from when the trunks are hollow and you can actually go inside a tree. I find that a very comforting thing to do, to be inside a tree or to be in the canopy of a tree. Anyway, so these all of these is happening. All of these years are creating an amazing ecosystem. This tree becomes an ecosystem in itself because it's supporting it, which an incredible amount of diverse microhabitats, both above ground and underground. And I mean, we can only imagine the reserves of bacteria that are there in their root systems that have been there for hundreds of years. And the trees on the above ground part of the tree, there's a wealth of cavities in the trunk and branches, crevice bark, rough bark, decaying ancient wood, aerial roots. And so it's not surprising that the tree having dead, decaying environments and growing environments, it actually houses an astonishing diverse amount of organisms that live and benefit and feed and benefit and interact with these trees, from fungi, bacteria, insects, birds of all types. So these are, you can't replace these trees. When people say, and this is specifically true for veteran and ancient oaks. I mean, when you cut a mature tree, and then say that you're going to replace it with a bunch of young trees, you just can't replace that complexity that was built with time, and that is particularly important particularly so with these veteran ancient oaks. So how did we bring together these two? So we have a technique that specializes in mapping the architecture of trees. And then we have these ancient trees, which have an incredibly interesting architecture. So of course, these two go together. And we designed a project. We came together with the Woodland Trust, who funded the project, and with the wonderful people of the Ancient Tree Forum. Emma was started this project as a working in the Woodland Trust, and now she's at the Arboricultural Association. You lucky people to have her. She's a wonderful researcher, and so we came together and with 3 researchers, Phil, Matt, and myself from UCL, and we came together to design a project that would be interdisciplinary. And the aim is to characterize and compare the architecture of these wonderful ancient trees across the UK using TLS, and with deliverables in mind that have a threefold. So there's a public aspect to this, and this is something that was super important to us. This project gave us the incredible opportunity of creating a digital archive, a digital legacy for the UK of these ancient oaks. I mean, this archive has already proved its value. Just earlier this year, the Crockmere oak fell over from storms, and that tree has fallen. But it was one of the trees that we scanned, so we have its digital twin to continue to study this tree. And so that is one really important aspect of this project that we were really excited about. And the Scatter Digital Archive, I'll talk to you about more further along the talk, but it's available in open source. Anyone can access it. And I think we're really proud of this, of putting this legacy resource out there for everyone to enjoy. In terms of academic, of course, deliverable, of course, it's just fascinating to compare and contrast the architecture of these trees across a spectrum of ontologies of life histories. This is, of course, fascinating work. And another really enjoyable aspect of this project was actually having the interaction with the tree specialists, with our people, the ancient tree form people. So we could develop the project, and we could develop the results, the data analyses, to help support the important monitoring and conservation work that these ancient tree specialists do. That has been hugely satisfying, and yes, and I will again talk a little bit more further on along the talk about this. So this is in short the Scatter project, and the team and our aims. And so how did we customize our methodology? So we used a Rigo scanner, which is the gold standard for collecting TLS data. And this instrument has a range of 400 meters, so we were able to capture the trees in their environments also, so which is going to be a source of research also, of data, of how the environment that these trees developed around. And so we end up, in the forest, we have a 100 meter plot. Here, we concentrated on individual trees. So this is the signing oak, one of the pampered royal oaks and at Windsor Park. And so we have this tree. What we did is we scanned around in different positions around these trees, under its canopy and outside its canopy, so we could reach above the canopy, so we could get a full scan of this tree. We scanned around the tree in every angle. And if there was a hollow trunk, we went inside. As you can see, we went inside the tree and scanned inside. And the result of this was a digital twin of each of the trees that we scanned. This is actually here, this tree in the video is actually the Crockmere oak, which sadly has fallen, but we have its digital twin, at least. So the fieldwork, what trees did we visit? So we went around the UK. We had a northern route and a southern route. We went from our department at UCL Geography in London. We went all the way up to Scotland and scanned around 20 ancient veteran oaks and along this route, and also one tree in Northern Ireland. The southern route took us to Wales, Cornwall, and Devon, and was another around 20 trees that we scanned. So yeah, I mean, wherever you are in the UK, you're likely to have a regional tree that you can get to know and explore its digital twin, and that's in our Scatter archive. So these are the trees. So here we have we were looking with these scanning of trees. We were looking to capture the diversity of trees around the UK, their locations. We have trees in Wales with unpronounceable names along next to roads. We have these two oaks are in red, highlighted in red, are the Meavy oak in Devon and the Darley oak in Cornwall. So those are my regional oak ancient trees. We have trees by rivers in Scotland. This is the Nilgau oak, which is named after the most famous fiddler in Scotland. He was known to enjoy having a tipple underneath this tree and writing his songs. So yeah, there's a variety of trees with different management histories and different environments in which they grew. So what was the data that we collected? As I mentioned, we had the scanners with the Regal instrument. We took drone videos so we could get information a little bit, again, about the surroundings in which these trees grow. The Insta videos, the surround videos, these also provide useful information about the environment these trees are growing in. And we also collected iPhone scans. I don't know, we've been having a great time training some people in the Ancient Tree Forum. Well, it's very simple to do these scans, but a lot of people didn't realize that, your iPhone, I think from the 14 iPhone, the iPhone Pros have LiDARs in them. It's not a very powerful LiDAR. It has a short range, but it can collect very, very good trunk scans to analyze all of the microhabitats of these trees, the trunks, the main trunk of part of the tree. We also collected tree-related microhabitat surveys, a trend survey, and we also tape measured DBH of every tree we scanned. So this is revisiting how we did the scanning with the Regal instrument. So just to recap, we took 6 to 12 scan positions around the tree. This would take around an hour per tree by the time we got really going and we're familiar with how to get around and capture the trees. So the pros are millimeter, as I mentioned, millimeter accuracy. We have 400-meter range, but of course these it's an hour investment and you have to travel to the tree. And of course, these instruments are not cheap. So yeah, it has its, but you can't get better data than with this sort of instrument. So yeah, and so after we collected this data, the processing of this data, so we have the tree, we have here, this is our tree of interest, our ancient of interest. From this scene, which we did a border kind of like a 10 meter around the tree. We segmented that, and then we segmented the tree out of that surrounding. The tree was then further split into trunk and canopy. This tree we scanned in April. So part of the canopy doesn't actually have leaf, but we also separated leaf from wood, and also we did this manually. Just for you ARF guys, we actually segmented individual branches. I think the record for our trees was one tree with 80 branches. And I can tell you that it's a lot of manual work, a lot of hours, a lot of days of work doing that. So just to recap about what are the components of analyses that we come out from these scenes. So we have the initial scene, we separate, this is the signing oak again, an example with the signing oak. We separate the tree from the rest of the scene. We separate the supports, and then we also model to get to volume and AGB and carbon. And like I mentioned, the canopy and the trunk are separated, and then the canopy is segmented into leaf and wood. Individual branches are also identified. And then we have those beautifully detailed iPhone trunk scans, so we can analyze microhabitats and get a better information about how trunk hollowness. And this is a little bit more information on the iPhone scans. So this method is quite simple. It's kind of like you go around with the phone and you kind of spray the tree. And so you move around the tree. It takes about 5 minutes, depending on the size of the tree. And of course, this is the cheapest LiDAR on the market. You can capture as many captures as you want. This was done with we analyzed a few apps that work with these captures, and the Polycam app was the best that we found. And the app is free to use, but when you want to export the models, you do have to have a subscription. And the limitation, I mean, this is wonderful. This is, as you can see, these scans are wonderfully detailed. I went inside this tree very carefully to scan the inside. They're super detailed, but of course, because of the range, the limited range of the scan, it's only the trunk that you get out of the scan. The whole tree you get with the Regal scanner. So we also did structure from motion. So if you don't have LiDAR on your phone, you can also take a video. It's the same concept. You go around the tree. This is Offa's oak, the oldest tree we have in our scatter archive, around 13 or 1400 years old. And so basically, you take a video of around the tree, and then you have a processing software, and it requires a lot more. It's not as easy, but it struggles to capture finer details. And yeah, the post-processing can be tricky, and really the iPhone scans are quite superior to this. So we didn't really, we preferred the trunk scans to this method, but it's also available. Drone data. This video actually exemplifies, this is the curly oak, dedicated to Professor Rackham, the father of forest ecology, landscape ecology in the UK. And this drone video highlights something quite interesting to this little tree as it gets further up and the viewing angle expands. You will see that this little oak is basically, you can start seeing, surrounded by a conifer plantation. And what this video made very obvious is that these conifers are shading this little tree. And we were talking about that it might be an important management decision here to be made to cut more of the trees around it, to open a bigger space and allow more light in to help keep this beautiful little tree going for as long as it can. So yeah, that's the drone data and that we captured. We also captured the 3 Insta videos. This is available on YouTube. And as you can see, I mean, these are really sorry. So these are really these videos have sound, so they really immerse you into the environment of the trees that we scanned. So I really enjoy these videos. This is Offa's oak, as you can see. And we were very lucky throughout the whole field trip that we did in May in 2023. We had the most wonderful weather everywhere we went, Scotland, Wales, Cornwall, everywhere. So it was like this all the time. So we're very lucky that those videos came out very nicely. We had very good weather for it. But there is also some people that, the sensation they get dizzy. So, but put into goggles, the immersive experience is really enjoyable if you don't get a bit seasick. So going back to the aims of the project, just to remind you with this slide here, I'm going to start talking to you about the results, the deliverables that are the result of this project. So one of which we are really proud of. So the digital archive, it's available for you. You can, if you the QR code is right there for you to go right there to connect, and you can get up close and very personal with all of these trees, explore them, go in, go out, look up, look down. I mean, these digital twins are super enjoyable to play around with. And they're all there, open source for everyone to enjoy. A little bit on the stories of these trees. We have the Meavy oak right here. It's a beautiful tree, around 900 years old. And these oaks have wonderful stories around them. The communities, they have involved communities that have relationships with them. And I mean, I would really encourage you to carefully and respectfully visit trees that are near you, or, explore them digitally. They're very interesting, and the archive have little snippets of their histories. So to give you a context of the tree. Another tree here is the Darley oak. This is a lovely, lovely tree that is located in the Darley farm. And the family that own this tree are super lovely and super welcoming. And the owner, Mrs. Hoare, I don't know how to pronounce her surname, I'm sorry, but she was the most lovely lady. She invited us into her house, gave us a cup of tea, and told us all about the tree. And in no uncertain terms, she told us that this tree is female, and she's named Emily. And there is a lot of folklore stories around this tree, that it has healing properties, that if you make a wish, it'll be granted. And I thought it was really interesting that this tree had very female connotations, and also the acorns of these beautiful tree had been used by pregnant women as good luck charms for a good pregnancy. So I thought that was a really lovely story around this tree. This one is another fantastic tree. Now, I included these Google View snap here because this tree is, I mean, we should be really replicating this. This is an enlightened developer that, instead of going in when constructing, this is a council housing estate, by the way, and instead of going in and cutting down this tree to build houses, they decided to make it a feature. It's called Crescent Oak. They designed the entire housing estate around this tree. As you can see here in the digital twin, there's a community around that. It's in constant view of this tree. And this is the most happy tree you can imagine. There's loads of seedlings growing around it. It's in really good, it looks really healthy, and there's even a swing on it. There's a bench for people to picnic around it. And the community is really, really involved with this tree and love their tree. And on the side of, I also included an image of a pollarded tree. That was the last pollard that this tree went under, I believe, in 2011. And just to show you the pruning, the pruning technique. I just thought it was interesting to see how these pollarding works. And this is I really hope that these we can replicate these onwards into the future. Wherever there's a tree, let's make it a feature rather than cut it down. So this is it's also a really special tree. I mean, they're all really special. We kept, Phil and I, when we were visiting and scanning these trees, we always thought the one we were at was the best one. And then another one came along and we just fell in love with each and every one of them. But this one is, although it's not the oldest tree, it is massive. It's by far the oldest, the biggest tree. It might be, I don't know, the biggest oak in the UK. People are known to burst in tears when they visit this tree. It is, and I included, you have the tree there, it's digital twin, and I included this picture because right there, if you pay attention, it's me. Just to give you a sense of the scale of this tree, I'm sitting right there in that opening, basically, and this tree is impressive. It's living its best life and exemplifying an apex in oak tree architecture. It's a wonderful tree. And this one you can't visit all the time, but they do open visiting, some years for a short period. So yeah, keep an eye out for getting a ticket to go and visit this tree. It's really special. Also, the digital archive, the actual data, is also available for anyone and everyone. And it's a Zenodo archive, and there's the QR code in case you're interested in the actual data. Also, as I said, really important to me and my colleagues, Phil and Matt. It was this knowledge sharing that we had. We had 2 knowledge sharing workshops at Ashton Court in Bristol. This is a scan we did during one of the workshops. That's everyone that attended the workshop on the Doomsday Oak. And it was just so interesting and so nice to actually hear about what you guys look for when you're monitoring and trying to do work to these trees. And so it was really interesting for us to try to tailor our analyses and our results to try and support the important work that arborists do, that the ancient tree specialist arborists do to protect and keep these wonderful trees going. And it was really surprising that actually during one of the really nice things that we found out was that actually just having those 3D images of the trees in itself facilitates communications, evaluations, consultations among specialists. So to decide, you have the architecture of the tree where if you decide that an intervention, you have the 3D architecture of the tree to work with. And every practitioner is working off the same image. So that is also quite practical, because if you take your own pictures and somebody else takes their own pictures and they're working out of different images, it gets difficult, and especially with these very, very peculiar architectures of these trees, it's really we've been told that it's quite nice to be able to everyone have these 3D images that they can work out off and make their decisions. So we're really happy about this. Continuing on, for a little bit of the academic analysis, this is very, very urgent, very, very early stages of the analysis. This is just kind of us getting a feel for the data. And we were looking at what makes ancient oaks unique, their architecture, of course. We're talking about their structure. And here we have a graph that shows on the y-axis the crown radius, the expanse of these canopies, and stem diameter. And so we have, right now, we're looking at the data, we're not looking at the scatter data. These are all oak trees. These are not ancient trees. These are young trees, mature. These are mostly mature trees. And you can see what the relationship of the crown radius to stem diameter is on all of these trees. Now, when we add the scatter trees, we can see that they're using a completely different space on this graph. They have reflecting the unique architecture that they have. And as you can see, there's very little overlap between ancients and younger trees. So that in itself is quite interesting to observe graphically. And then in this other graph, we also have again we have oaks. Here we actually have I did my my master's research project at Westminster Wood here in Devon, a really beautiful relic oak wood, and I added the data that I have from that site here. And those are these blue triangles. And so here we're comparing height of trees to stem diameter. And again, when we bring in the scatter trees, they are confirming what we know about their uniqueness. They use very different space. They have very unique architectures compared to other younger trees. So going forward with these analyses, we're, like I mentioned before, we're looking to compare and contrast ancient oak tree architecture among themselves in trees that have different management histories, like, for example, pollarded versus maiden trees that have never been pollarded, depending on their location. And also we have both oak trees from the two UK species, Quercus robur and Quercus petrea. So we will be developing these analyses further. This is just a little taster for all of you. And we're going to be, of course, publishing papers on these data, scientific papers. And I guess that's it. Here I leave you with the Wisham tree. Phil made these animation last year. Every year, Phil makes a Christmas tree from one of our trees that we've been collecting from around the world, or we've been scanning from around the world. I really love this one, and yeah, I thought you might enjoy it. So yeah, thank you for being here, everyone. And if you have any questions, I'll be happy to answer.
Brilliant. Thank you very much, Cecilia. That was great. Everyone's very happy. Even the dogs come over. Can I say hello? As people have been asking about you. Here's the dog. Fantastic. Thank you very much. Great presentation. Really, really interesting. And some wonderful trees you showed there. Some of them I've been lucky enough to visit myself. So it was nice to see the Mevio oak on there. Right. We've got lots of questions in here. Where are you going, Muff? You going to sit there? Okay. We have got lots of questions. I'm just going to kind of run through them. Some of these are very technical questions. I hate it when I have to ask technical questions that I'm saying words that I don't know what they mean, basically, but I'm gonna give that a go on some of these. The first one we've got, Paul has asked if the scan data uses AI to automatically calculate what species the tree is in your forest scan mode.
Sorry, say that again.
So when you're doing the forest scan, is AI used to automatically identify the species of the tree?
No. So we normally have for species, we collect census data, tree census data, and then we collect the TLS data. And then, so we are trying, and this is also something that we're developing. It's in development to kind of marry those data sets together. And so, like for the Wytham Woods plot that I showed, and I perhaps forgot to mention that the coloring of the trees were indeed by species, and that is determined by the census data. So it is not determined by AI. I can't hear you.
I muted myself to avoid, I think, me talking to my dog, but I've stopped now, so it's fine. I didn't think I'd turn into one of those people, but here we are. Right. What else have we've got loads of questions here. I'm just trying to work out which ones. Another question from Paul, a technical question. Does the software use its own 3D modeling file and program, or is it an overlay to DWG or CAD software?
No. So once all the data that comes out of the scanner, the Regal scanner, has its own proprietary software. And so this is, you remember that week that I mentioned of processing? So yeah, so basically the data out of the scanner goes into Rescan Pro software, which is the proprietary software that goes with the scanner. And so that's where we register. That's where we do the process of registering. What that means is basically weaving together all of the scan, putting together all the individual scans into a whole scene. Okay, so then after we have that, then we go off, we pre-process the data to go from the data format of the scanner to PLI format. And that you can basically, PLI format is very, it works in a lot of different, like Cloud Compare, you can load it onto Cloud Compare to view the data. And from there, we use supercomputing to do the processing. So then we basically tile all the data, like a 1 hectare plot. We'll separate into 10-meter tiles, and then we identify leaf and wood. We segment leaf and wood, and then we extract the individual trees and then model them from there on. Mm-hmm. So it's a long process of processing, but the format is PLI, which is a very .ply. So it's a very versatile format of data. I don't know if that answers that question.
I don't even know what the questions mean that I'm asking, Cecilia. I have no idea, but I hope it's answered. You seem to know what you're talking about. You convinced me. Thank you. Right, let's ask some questions that I might understand. So a couple of people, Ian is one and Andrew is another one, have asked about, can root systems be 3D mapped as well? Obviously, we know the importance of roots, but also the carbon sequestration of roots as well. Is there any technology that allows us to use similar technology, but underground?
I think TLS, no. It's basically, the nature of the technology, it works with firing thousands and millions of lasers, and those create the dots, basically the point clouds that basically represent a scene. So you need contact. So underground, I think I'm not very familiar with the technologies that are used there, but maybe radar.
Mm-hmm.
I want to think radar maybe, or something like that, some kind of tomography. But I'm not sure. I haven't worked in roots, but I am getting, because of these trees, I'm getting super interested in roots. That business with those aerial roots that come in and, that they start growing to self-recycle. It's amazing.
Well, as you mentioned, the aerial roots, you might not have anything there, but Darlene was asking if there's any pictures of the internal aerial roots, because she says she'd very much like to see them. So I don't know if you've got anything to hand on your computer you want to share, if there's any websites that might contain it. But
I don't. But the Polycam scans, that's where you want to look. So all the Polycam trunk scans will have some of the roots. So I try to capture a little bit, not just the root, the tree base. So I try to capture a little bit of the root base around the trees, and I can think of the Nilgauss oak. That one, because it's at the bank, a riverbank. The actual rooting system to one side, on the side of the river, is quite exposed. So there is some of that captured in the scans for that tree, the Nilgauss oak.
Fantastic. And that's available on the website. You have the QR code too,
yes.
Yeah?
Yes.
And
also on the data set, and the Zenodo data set, because that's where the Polycam trunk scans have not been added to the scatter, to the archive, the digital archive. We're discussing if we were going to add them or not, but they're definitely in the Zenodo archive.
Brilliant, thank you. And as a wonderful piece of marketing, Callum has said that the Arb Association workshop he's planning will focus on Polycam. So we're going to be doing some training in all this sort of thing at the beginning of next year. And Callum is on it.
I'm really happy that arborists have just really really like this. I started doing it because of Vicky Bengston. She's a microhabitat specialist, of course. So I collected those for Vicky because I was doing the TREM survey, and I mean, we couldn't, our priority was scanning. So the TREM surveys that I did were very basic because we didn't have time to do these surveys. It takes a lot of time to just, with binoculars and everything, to really write down all of the different features that these incredible trees have. So I just knew that I wasn't going. We just didn't have the time to do justice to these surveys. So the polycams was my technical solution. And so yeah, Vicky's very happy seeing those. And when we showed those, they're very popular. And like I said, in those workshops that we did at Ashton Court, we went around and I demonstrated, doing the scans and all that. And yeah, I mean, if you got an iPhone 14 or up Pro, you've got a LiDAR right there. Get out there and volunteer to go scanning these trunks. I mean, it's amazing.
I think Callum and Andre say in the chat it's an iPhone 12 and up, I believe. I think that's what was said in there. So
excellent.
I have no idea, but that is what someone said in the chat. So who knows?
I find it to be honest. I find it absolutely amazing, the wealth of knowledge of the natural environment of the UK. I mean, because I don't know, you Brits might not, because this is your country and you might not realize how unique this is, but the time that the people in the UK, the time and energy that they're willing to give to go and find these trees, orchids, birds, whatever it is that rocks your boat, whatever you're interested in. It's like Brits are super generous with the time they give, and it's amazing. I mean, having these registry of ancient trees, I don't know that any other country has such a resource, and it's all due to all of you guys, the public, the volunteers, our society, Ancient Tree Forum people. I mean, I think it's something that is really worth recognizing about. Hey, that there is a lot to do with these trees, and let's not forget that the Scatter project was also I should have also mentioned this, that is designed to support the Living Legends campaign, the Woodland Trust Living Legends campaign. Let's super important to mention that. And this campaign is campaigning to offer protection, legal protection to these trees, which is, if you think about it, it's madness that they're not protected. I mean, how can a house, a building that a human built, with the resources of this nation, 200-year-old protected, while a tree that is off the land, that has used the air, the sun, the soil of the water of this land, and has been growing there for 1,000 years, how can this not be a patrimony, considered a valuable patrimony? And these trees, like I said, they have relationships with their communities. They have been used as shelters for farm animals. In their hollow trunks have been used to shelter farm animals from storms. They have been used as places where families go and have tea parties. They have been used as, this is a little bit of a more ropey part of history, but as chaining trees and hanging trees. They're there, the history, they're part of that history. As boundary trees, they have witnessed, sometimes they have witnessed battles and that raged around them, and they're the only living organism that's still alive after those battles. So that blood spilled on that land that they grow on, they're of this land. They for me, it's a no-brainer. They should be protected.
Absolutely. Well, I agree. I think you're talking to a very open audience to that kind of thing. You're absolutely right. And I think the Woodland Trust presented the petition, didn't they, to
Yes.
Downing Street? Was it last week, I think, maybe?
Yeah.
Because it's National Tree Week, of course. I should have said Happy National Tree Week to everybody, but they took it down there for National Tree Week.
This is a perfect talk for this National Tree Week, of course. And the petition was submitted last week in London with 100,000 signatures. Go and add your signature if you haven't yet to the petition. And Northern Ireland is unfortunately the legislation that was going kind of starting to go because of the call of the new election. It kind of went back to the beginning. So, but Northern Ireland have taken on have basically have come up with their own document for protecting their own campaign for protecting their ancient oaks, and they are pursuing quite successfully so far, the protection of these trees in Northern Ireland. So there's a lot of good news on this front, and I know that there's been also some sad stories like the gap tree and things like that, but there is a lot of good work that is being done around these trees, and we need to work harder to get them protected, basically.
And I think what's one of the great things about this project is it lets people see them in a different way, doesn't it? And it lets people almost visit trees that otherwise they might not be able to visit, which makes people, I guess, if not care about them more, then at least feel more of a bond with them, perhaps, that they've got to see them in a way that they've never seen them before.
Absolutely. I mean, my father-in-law, he's a Londoner, and he's a very keen gardener and observer of the natural world, and he loves trees. And I've really enjoyed introducing this project to him, and I show him because he's elderly, so he's not very techie. But I've shown him all these digital twins, and it's been a hugely enjoyable. He's 86. He's not going to be able to go and visit these trees, but he still can experience them through these digital archive.
No, that's amazing, and I love the fact it's all online. It's great that it's all open source and online and available there for people to look at as well. It's really, really fantastic.
We're really, this is a legacy, archive, and we're really very proud of putting this data out there, and we're so looking forward to people enjoying and interacting with this data. Like I said, you can get up close and personal with these trees.
Yeah, absolutely. And we've got lots more questions. I'm not going to get through them all, but a couple of interesting ones. I'll sort of pick out one from an anonymous attendee, but asking if there's any plans to go back and rescan any years, 5 or 10 years later, because I feel like that must be a natural progression to this project. It would be incredible. You could almost watch them growing in a sort of flicker book type thing. Exactly.
I mean, we would love to. It's finding the funding. I mean, we're up for it. The team at UCL, we have the equipment and we're up for it. We just need, we will need the funding to keep this monitoring program. But absolutely, you're absolutely right. This technology is a wonderful way of monitoring these trees, and rightly deserves to be developed as a protocol, a decade, 5 years, 10 years of monitoring as part of the monitoring and looking after of these trees. There should be this considered as part of it.
Yeah, well, that'll be exciting to watch as we go along. Callum has asked a question. First of all, he said, great presentation, thank you. But Callum's pointed out that one of the long-term ambitions of the project is to create this digital archive. And he's asking, what's the biggest barrier to increasing the amount of data or trees that you can collect to achieve this aim? And how are you going to overcome these barriers? I suppose we mentioned funding is one of the main ones of building a comprehensive digital archive.
Is the number one barrier, having the funding to do it. I mean, the other thing is related to funding. These instruments, like I said, the instrument ones, because it comes with a GNSS system. So it gives us geolocation. So the whole package is about £90,000. So we have two scanners actually. And so that is a limitation, of course. With funding, it can be solved. People, I mean, we need people to go and do the scans. I guess we could train more people to do it. We do that all the time. I mean, I can't think of any other limitations really. We would love to repeat these experience. I mean, me personally, I have lived I'm from Mexico, like I said, but I have lived half my life in the UK. My husband is British. My life is here. My research is based here. I go to the tropics from here and around the world. But I think, I can't remember where I was going with that. Sorry, I lost track of where I was going with that. But I mean, yes, this trip, and as a foreigner, it gave me the opportunity to explore this country and see the countryside of the UK in a way that I'd never seen it before. And my gosh, is the UK a beautiful country? The countryside is wonderful, and of course, I would love to repeat that experience.
Absolutely. Well, we certainly do have incredible countryside. It's a shame in a way that we haven't, we couldn't have Rob joining us tonight. We said this at the beginning, but his talk was about saving the Darwin oak. And obviously Rob McBride, the tree hunter, is someone who goes out there and sort of discovers new trees. It always amazes me how many centuries old trees we've got in the UK that no one's kind of clocked as there properly. We can still find new stuff. It's still very exciting to be able to go looking for these trees as Rob does.
Yeah. I met Rob at the oak at the Gate of the Dead. Very dramatic name, because this is one of those trees that was in the middle of a raging, bloody battle all around it. And I really remember that, because it made a big. He told us the story of these trees. I mean, there's some information there around this tree, but it really moved me, that the fact that this tree was there, and it's growing in that land that was soaked, that all of that battle, and that tree keeps going. It's still there, and I don't know. I find it very, very moving.
No, it is. I agree with you, and it's. For me, certainly, it's those kind of connections that are the things you can't quantify. You can't put a value on that. I think whilst it's brilliant to quantify trees, and there's wonderful tools out there to do that, it's very important as well we don't lose sight of those things that you can't put a monetary value on, which is being in the presence of this living thing that has seen so much. So, yeah.
Absolutely. This is one of the enjoyable aspects, the many enjoyable aspects of this project, because it's interdisciplinary, and there is so much history and culture in these trees also of these UK. So it's in the aspect of working with the practitioners that look after these trees. So it's I mean, these are amazing trees.
So Callum has pointed out that he did ask a sort of second part to that question. You asked two questions, Callum, and I'll ask your second one now. So his first one was about what are the barriers. We've established a lot of it's to do with money. I'm going to paraphrase your second question, Callum, because there's lots of words in it. But basically, is there a way we can overcome that funding issue through some of the low entry barrier methods like phone scanning, for example? Is there a role for, and I'm going off Callum's question here, but sort of citizen science iPhone scanning type technology to supplement your data?
Absolutely. I mean, nobody's stopping. I mentioned that there is the Ancient Tree Forum, and the Woodland Trust have armies of volunteers that go and visit these trees. So that's one of the reasons I push the iPhone scans quite a bit, because, like you say, indeed, it's an accessible source of information, and a very important one for monitoring, the main trunk. I mean, anyone can join in. I mean, there is no reason why. I mean, of course, the volunteers would have to have iPhones, But yeah, I mean, that whole army of volunteer can be, activated with iPhones, and yeah, these archive can grow quite quickly.
Brilliant. There we go. There's a citizen science project waiting to happen there, I think. A couple of people have asked about wind. David's asked if LiDAR scanning is affected by windy conditions, and Anthony's asked the same thing. How much does wind speed affect the accuracy, both on the leaves, obviously, which are very mobile, but also on the scaffold branches, which sort of move a bit more slowly? What's the impact of wind on your work?
Indeed, good question. It's not only wind, it's also fog, and it's also rain. So if you think about the technique, so we're sending lasers, actively sending lasers. So like a normal camera, an RGB camera, is a passive instrument. So it's just receiving the light reflected from the scene that you're observing, right? With TLS, this is an active system. So it's actively sending thousands and millions of lasers to create those point clouds. And so... So you're creating these images of the trees, and yeah, I mean the phone is a super practical tool for that.
Brilliant, thank you. Excuse me, God, I'm coughing so much, I don't know why. But what other questions I want to ask? Ian has asked about, with the very high resolution that you can achieve with TLS, can that also allow identification of the organisms living on or in the tree? Can you go sort of beyond the tree, whether that's fungi or other flora and fauna growing on it?
Yeah, sorry, I just realized that I didn't finish answering the previous question about wind and fog and rain.
Oh, yeah.
So yeah, the reason what I was saying that it was an active system. So if those lasers are being sent and there's rain and they hit a raindrop, then you're mapping the rain, you see? So the same happens with wind. If you think, the scanner is doing this, so you're trying, let's pretend this is the tree, and it's basically doing this, landing all of those lasers, right? So if the wind is not a problem if just the leaves are moving a bit. I mean, there will always be that. It's inevitable. However, once you get wind that starts moving branches with their leaves, then you start getting, if you think about all those lasers, again, you're mapping the movement of the tree, not the architecture of the tree. So the scan becomes a mess. The same with fog. If it's really dense, those water droplets are big enough to make for the laser to hit them. And so again, you're basically scanning the weather conditions rather than the trees. So yeah, those three, you have to be careful. On the other side, because it's you can scan at night. It doesn't rely on light whatsoever. And we do sometimes when it's really windy conditions during the day, we just need to be experienced at working in forests because, visibility is not as good as during the day. But yeah, scans can also be done at night. Sorry, and the next question, what was it? Because now I forgot.
Yes, the next question was about can the very high resolution that TLS can achieve be used to identify organisms living on or in the trees?
No, not really. I guess by association, maybe, but you don't detect. I mean, basically, it's a contact. Whatever is there, is going to register, right? So, I mean, if there is, like, for example, when we're scanning and there's a bird flies through this, when we're scanning, you'll see the bird going through. But basically, we normally get rid of that data because that's not in our interest. But when you're hitting a tree, I mean, you're getting the surface of the tree. You're not really. Some scanners, I mean, you have some reflectance data where you can tell, and that we use to differentiate between leaf and wood. because the reflectance is different. But no, you can't detect really living organisms. I mean, they would have to, like a squirrel, maybe if you're scanning the tree, you might be able to see it, but then it'll move really quickly. So it'll be kind of like a blur. So yeah, no.
Fungal brackets, presumably that would be picked up and scanned and identified. Yeah.
Anything that's there permanent on the surface of the tree will be recorded.
Great. And just looking in the chat, we're very honoured that we've got Vicky Benson watching the webinar. Hi, Vicky. And Vicky said that it was possible to identify some of the epiphytes on the trees from the scans. So there are some additional bits. So thank you, Vicky.
Yeah.
Good stuff. Anthony has asked, what is that little seedling tree conspicuously situated behind Cecilia?
Here.
Yeah. Would you like to tell them about your tree?
Let me bring it closer. This is a 2-year seedling of the Majesty oak. I do bonsai trees, and it was ancient oaks that actually got me very interested in it. And so the gatekeepers, the people that look after the Majesty oak, were so kind. I told them we were chatting with them, and through the conversation, I mentioned that I do bonsai. And at the end of our scan, one of them just came over and said, "Here, you can bonsai the seedling from the Majesty oak." So that's one of my little treasures. I also have one of the Bowthorpe oak, and yeah, they're my little green treasures, nature treasures that I have, and I look after them.
Fantastic. And as we mentioned this before we started, but I always say about I find bonsai fascinating because we have so much to learn in arboriculture from bonsai. And we had a great webinar from Amelia Williams a couple of years ago. Some of you out there may have seen, but where Amelia was talking about the,
is it still available?
Yeah, it'll be on the website somewhere.
Look it up.
And we should do more as well, because I think it's really something we can learn a lot from.
I mean, the connections, it's very similar work, but just in miniature. I mean, it's helped enormously doing bonsai with my tree physiology knowledge, and how, I mean, in architectural, I mean, all of these kind of moving the tree, weighting and rearranging the branches and those veteranization features that you bring in and all of that. It's all that.
Brilliant. Well, you've got a good collection. You got there's a lot of pressure on you now though to make sure you bonsai them perfectly, as they're such special little ones.
I know. This one has still 10 years to grow. That it's not on a bonsai pot. It's an air pot, so the rooting can grow very vigorous, and but it's normal soil. So normally when you're starting from seedlings, you have to give them at least 10, 12 years, especially these slow growing trees to grow, so you can have something to work with. Yeah. And then there's periods where I didn't know this also, you put them on the pot, and then if you want to grow them more, get thicker, you put them back into the soil and you let them grow up and, build up, and then you bring them back onto the pot and then you reshape them. And so it's a really interesting process.
Wow. We'll do another webinar.
Relationship. It's a living work of art.
Yeah. We'll do another webinar in 50 years and you can show us how it's gone.
I'd love that. It'd be terrible if it didn't survive, though.
It would be quite embarrassing. I do this from my home office now, but previously when I was doing it from the malt house where we're based, I had a succession of houseplants that would die gradually over a series, and people would get more and more upset with me that I was killing my houseplants. So you're definitely not allowed to kill your bonsai. I got enough hassle for the houseplants.
I promise I will do my best, and I normally have very green fingers. So my house has got loads of houseplants and that.
Well, it's better it's with you than with me then.
I'll do my best.
Yes, well, good. Well, we will check up on you. We've got time for just a couple more questions. One question is, are you aware of any other sort of comparable studies like this? Well, they've asked in the US in particular, but even around the world. Is this something that we're just doing in the UK, or this kind of study, these sort of digital twins, particularly with the online resource? Is there anything like that anywhere else?
For ancient oaks, you mean?
Yeah.
Not that I know of. And really, the UK is the country that has the most ancient oaks in the whole of Europe, or registered, that we have a list that we know of. I mean, there are, like in Chile, that there's the Fitzrovias, in California, there's the redwoods. But in terms of numbers, I believe the UK is a country with the most recorded ancient oaks. And that I know of, I don't know of any other country that has this official list of ancient oaks. And I've been talking to a colleague, a fellow researcher. She did her PhD in my same group, and here in the UK, she's from Chile, and Rocio Urrutia, and we're trying to kind of talking about going and scanning some Fitzrovias, which can live for several thousand years. But yeah, I think every country should have this resource. Every country should have, the legacy of their natural world identified and recognized and protected. I mean, yeah.
Fantastic. I don't think we can really finish any better than that. You're absolutely right. I will ask one final question, and that question is, what is your favorite tree-related book?
Well, I don't know if I have one favorite, because there's loads of trees, there's loads of books, but I'm currently very enjoying very much in reading Elderflora. It was recommended by Matt Disney at UCL, my boss, and I'm really enjoying that book.
Yeah. And that's sort of a bit of mythology in there as well, isn't there? And some of the stories of some of the ancient trees around the world, I think.
Exactly. I think this is something that really attracted me about this project, that these trees have not only incredible biodiversity significance, both for their above and underground environments, long-term environments that they provide. They also, there's this history, those communities that have interacted with them, and all of that history and culture that is there with these trees. I mean, anything that lives a long time has a rich history, right? So, so yeah, that aspect of the trees also very much interests me personally. I mean, first I look at this study, I look at the scientific data, what our scientific aims and that, but I also pay a lot of attention to, those relationships that we have with those trees.
Mm-hmm. Brilliant. Thank you so much. Well, look, that was a wonderful presentation. Thank you. I think everybody out there absolutely loved it. We had more than 400 watching it as well. So it's absolutely brilliant and a great project. We look forward to hearing more about it. We'll have to get an article in the Art magazine or something if we haven't got one already. I'm sure Emma Gilmartin's going to be on that, but we'd love to do that. So thank you so much, Cecilia, for your presentation and your questions and answers. It was great. Thank you to all of you watching. You're all wonderful out there. I hope we will see you next week for our next free webinar, which is going to be great. It's about the nature of our cities and the Wood Wide Web, and some controversial takes on the Wood Wide Web. And then lots more webinars throughout the series, loads of stuff to go out there and enjoy. So thank you, Cecilia. Thank you to all of you. Thank you, Andrew, for doing the stuff behind the scenes. Have a wonderful week, and we look forward to seeing you this time, or not this time, an hour and a half earlier next week. So thank you very much. Good night.
Good night, everyone. Thank you for being here.